I was just thinking about simple experiments we could do to try and see if CO2 is really having that much of an impact on the atmosphere. And I thought about this idea of just using a kind of a simple sealed container filled with air and filled with CO2 and see whether or not the pumping in of CO2 into the container changes the temperature at all, whether or not it manages to hold on to more radiation from the background and thereby increase the temperature of the container. I guess that'd be a very simple experiment to do. And I came across online this simple experiment put up by the Royal Society of filling a balloon with CO2 and filling a balloon with air, and then using a 50 degrees C heating element in the balloon to see how the two cool down by comparison. And yeah, air does cool down a lot more quickly than CO2, it seems. But I'm just wondering that whether or not this is still impacting the environment, and considering that the Earth isn't really a closed system as such. It is an open system with us losing atmosphere to space every year, with us accreting material also from space as well. And I'm just wondering like how relevant that is in those two sorts of settings, when it's a balloon filled with CO2 and it's a sealed container filled with CO2. I just wonder which experiment out of the two that I have been thinking about would be the most relevant for really trying to gauge this. Would it be having a sealed container full of CO2 instead of a balloon that's been heated? And we're just trying to figure out whether or not the addition of CO2 in general, or having a whole container filled with CO2, raises its temperature above an equal container, and a container of equal size filled with air. Whether or not the fact of having a CO2 environment that is already at thermal equilibrium with its environment, whether or not that makes any difference to the temperature of that environment, if you see what I mean, which I don't think it should actually, because I think irrespective, and this is the point, it may lose temperature more quickly, the air. I don't think I deny that. I mean, that seems to be robustly well proven, I think, by simple experiment, and the Royal Society's published it, so I'm not really going to argue with that. But I think my point is, like, however long it takes for it to lose the temperature, to lose that heat, it still does lose the heat eventually. It still does lose the heat to space. And CO2 that's been pumped into the environment, I think that is at thermal equilibrium with its environment and does reach the thermal equilibrium with its environment quite quickly, irrespective of irrespective of its concentration, if you see what I mean. I still don't think CO2 heats the environment. Because still, what would be heating the environment in this example, in the environment of the balloon or the environment of the container, is the distance from the heat source, or the nature of the heat source from the object. So what they're doing is they're putting a heating element inside the balloon and then taking it out again. But that's the equivalent of moving the Earth closer to the sun and then away from it. If you were to have loads of CO2 in the environment, sure, move the Earth closer to the sun and add this heating element to this unnaturally high degree temperature, 50 degrees C from our perspective on Earth, and then move the sun away again. With an atmosphere of CO2, it might lose heat more quickly, slowly, but still it would lose heat nonetheless. It's a bad experimental design. It's a poor gauge of whether or not CO2 is really going to heat our environment. The reason for that is because, what am I trying to say? It's the distance to the heat source that makes the difference to the temperature, not the environmental composition. So what you really need to do is you need to take a sealed container of CO2 at thermal equilibrium, and then compare that with an atmosphere of air at thermal equilibrium to the atmosphere and just let it cool down. If the CO2 never cools down to quite the same temperature as the air in the two sealed containers, then global warming is a problem. If it never reaches thermal equilibrium again, then it could be causing global warming. Do you see what I mean by that?